Okay, this is another video lecture for Math 140 Trigonometry, and the topic today, this lecture is for Tuesday, April 7th. The topic today is solving trigonometric equations. So we're now in chapter 4, and we've talked about inverse functions, we've talked about inverse trig functions, and now we're going to talk about how you might solve a trigonometric equation. What exactly is a trigonometric equation? A trigonometric equation is an equation that involves a variety of different trig functions. And one example, there are many examples. This is just one example. Sine squared of x plus 2 cosine x equals square root of 2. This is an example of a trigonometric equation. Okay, we see it involves a sine squared of x and a cosine x. And what we want to do, as usual with any equation, is we want to solve it for the values of x that make it true. Okay, so that's the goal for today, to learn techniques for solving trigonometric equations. The good news is all the standard rules of algebra apply when we're solving these equations. We basically want to isolate our variables. The added feature to this, beyond algebra, is we need to start using inverse trig functions to solve these. Let me talk a little bit about principal roots. So to talk about principal roots, because trigonometric functions cycle, like for instance sine of x cycles like this, right? Because it cycles like that, often you will have the different possible solutions will be represented by a horizontal line, typically the intersection of that horizontal line with various points along the function. So often what happens is you have more than one solution to a trigonometric equation. In fact, you'll have an infinite number of solutions, okay? And so we don't want to try to find all those solutions, but when we try to find what's called the principal root, what typically will be this solution right here. So the principal root is a solution that corresponds to a particular inverse function, like sine of x is defined, its inverse is defined just over this region. So we're going to look for a solution that's in the domain of the inverse trig function minus pi over 2 to pi over 2 for sine of x. I think this will make more sense when we do some examples, but basically there's many different solutions to trigonometric equations. We want to find the particular solution that's the principal root. It's the simplest solution, and then the other solutions follow naturally from that. And again, this will be clearer when we do an example, some examples. So actually today we're going to do 5 examples of solving trigonometric equations. So let's consider our first example. Okay. Our first example is sine of x equals 3/4. That's our first example. We want to find the solutions to this equation. I think the most helpful thing here is to create a graph, first of all. So we'll create a graph of this. Let's create a graph of sine of x. Sine of x looks like this. Like this. And it comes back up like this. There we go. Like that. And the way this works is we're trying to figure out the values of x such that sine of x equals 3/4. Well, sine of x peaks out at 1. It peaks out at 1. So the value of 3/4 is approximately right here. And what I can do is draw a horizontal line. And this horizontal line is y equals 3/4. Okay. And we want to find the places where sine of x equals 3/4. So we can see here we have many different places where that's true. We have this point right here. This is known as the principal root. Because if you remember when we talked about inverse functions, we limited the domain of sine of x to the region minus pi over 2 and pi over 2. Okay, so principal roots are roots that are within this limited domain. In fact, this is our principal root, but then I'm going to indicate these with open circles. We have many other roots. In fact, we have an infinite number of other roots. So we could find other solutions there's an infinite number of solutions to this equation. We could find try to find all of these, but that's a hassle. So we'll mainly be concerned with the principal root. But we can find these other solutions by using the fact that this is, for instance, pi minus this solution. There's ways to find these quickly, but we're going to concern ourselves with the principal root. How do we solve this equation? Well, the answer is we're going to take the inverse sine of both sides. And so I'll take the inverse sine of x. I can do anything I want to an equation as long as I do the same thing to both sides. I'll take the inverse sine of this equation, inverse sine of x. As we talked about, the inverse function undoes the action of the function, so this just gives us x. And we're left with x equals inverse sine of 3/4. Okay, and now you plug this in your calculator, and x comes out to a certain angle, and that angle is 48.6 degrees equals 0.85 radians. Okay, that is the solution. That is the principal root, or the principal solution of this equation. So if we come down here, right, the value of the angle for which sine of x equals 3/4, it turns out is 0.85 radians. 0.85 radians is the answer to this problem. Now we could find other roots. Let's find one more root. Can you guys see what this other solution would be? What is this solution here? Well, the way we find that is we know this point is pi over 2, or 180 degrees. We know this is 180. So the way we find this answer was we take 180 minus 48.6 degrees. And this gives us, it gives us 131.4 degrees. Or if you do it in radians, this is 2.29 radians. So that's another solution to this equation. In fact, there's an infinite number, and we could find all of these if we felt like it. We don't need to. Mainly we want to know the principal root. That's the solution to this equation. Okay, that's a simple trig function. Let's consider some more examples. So let me erase this board. Let's consider some more examples of this. Here's a second example. Example 2 is 2 tangent of x minus 3 equals 0. Okay, this is a little more complicated. This is a trigonometric function. We want to find the values of x that make this true. What we want to do is first isolate tangent of x. That's our goal. So to do that, I'm going to move the 3 over to the other side. So I'll add 3 to both sides. That gives us 2 tangent of x equals 3. And then I'm going to divide both sides by 2, and that gives me tangent of x equals 3/2, or 1.5. So now I want to find out what values of x make tangent of x equal to 1.5. Well, again, let's create a graph of tangent of x. This is our tangent of x. Okay, and tangent of x is asymptotes at pi over 2 and minus pi over 2, has another asymptote at 3 pi over 2. And then tangent looks like this. It comes up, goes through there, and goes like that. And then it does the same thing over here, like that. It repeats. This repeats. Okay, so we want to find the places where tangent of x equals 1.5. Well, if I label this as 1.5, okay, I can draw a horizontal line like this. You guys see that our solutions to this are the points where this horizontal line of 1.5 equals tangent of x. So I have a solution right here. This is my principal root, a principal solution. Then I have another solution here, and I have an infinite number of solutions because tangent cycles. I'm not really going to care about those too much. This is the one I'm interested in, the principal root. And again, I know this is the principal root because we limited, when we did the inverse tangent function, we limited the domain of tangent from minus pi over 2 to pi over 2. So we're really only looking for solutions in that limited domain. And this is the only solution in that limited domain. Now, how do we figure out what the solution is? Again, we take an inverse tangent of both sides. So I get the inverse tangent of tan of x Okay, that just equals x. And then that equals, if I take the inverse tangent of the other side, I get x equals tan inverse of 1.5. Okay? And if you plug this in your calculator, the answer to this, the value of x comes out to 56.3 degrees, or if you do it in radians, this is 0.98 radians. So this is the answer. This is the principal solution to this trigonometric equation. 0.98 radians or 56.3. In other words, tangent of 56.3 degrees equals 1.5. Okay, let's consider a couple other examples of solving trigonometric equations. The board's getting a little wobbly. Okay, let's consider a third example. Our third example is the equation tan squared of x minus 1 equals 0. We want to solve this equation for x. Like we want to do again is isolate tangent of x. So the first thing I'm going to do is move the minus 1 to the other side. So I get tangent squared of x equals 1. The next thing I do is take a square root of both sides. If I take the square root of something squared, I just get back the thing itself. So I have tangent of x. The square root of 1 is plus or minus 1. Okay? So that's my answer. Tangent of x equals plus or minus 1. I need to find the values of x for which tangent of x equals plus or minus 1. If I create a graph here, let me create a graph right here. A quick and dirty graph of tangent. Like this. Here's my tangent. It's going to go up like this, go over and come up like that. Okay, I'm going to draw the two lines here. This is minus 1 and this is 1. I'm going to draw a horizontal line across like this. Okay, like this. And I actually have two principal solutions to this. I have two solutions to this equation within our domain of minus pi over 2 to pi over 2. Okay, and those two solutions occur right here and right here. These are my two principal roots. Okay, and to find these, what I do again is I take the inverse tangent of both sides. The inverse tangent of tangent just gives me x. And then I have the inverse tangent of plus or minus 1. Let's consider each separately. So one value of x is the inverse tangent of minus 1. Inverse tangent of 1, which equals pi over 4. Okay. The other value of x is the inverse tangent of minus 1. That equals minus pi over 4. Those are my two solutions. Okay. So these two solutions, these 2 points, are pi over 4 and minus pi over 4. Those are my two solutions to this equation. So sometimes you might have more than one principal root. This is a good example. Okay, let's do two other examples. Again, I'm making these videos fairly fast to limit the size of the video, limit the upload time. Upload is taking a long time these days. Let's consider another trigonometric equation. And this equation is a little more complex. 2 cosine x times sine x minus cosine of x equals 0. Okay, we want to solve this equation for x. Okay, now this is trickier because now we have both cosines and sines involved, and it looks like it might be pretty hard to isolate. You know, how do I isolate? Since I have both a cosine x and a sine x, I can't just isolate cosine x or isolate sine x simultaneously. I can't really do that. So is there any way I can solve this equation? It seems hard to isolate our variable. Well, one thing I can do is factor this equation. In factoring, we haven't really talked too much about factoring, but hopefully since you guys know some basic algebra about factoring, factoring means you pull out any terms that are common to both of these terms. Do we see anything that's common to both of these terms? Well, cosine x is common, so I'm going to pull cosine x out. So I'm going to factor out cosine x out of these two terms. What I'm left with is 2 sine x minus 1. If I factor cosine x out of these two terms, I'm left with 2 sine x minus 1. And this all equals 0. And then there's something called the zero product property. Okay, and that says if a times b equals 0, then a equals 0 or b equals 0. And that's the idea behind factoring. Basically, if I have one thing times another equals 0, then either this term has to equal 0 or this term has to equal 0. That's a basic algebra principle. It's the idea behind factoring. If you have a regular equation and you factored it, such as x squared minus 2x equals 0, you factor out x, you get x minus 2 equals 0. This means either x equals 0 or x minus 2 equals 0. That's how you solve an equation with factoring. So either cosine of x equals 0 or 2 sine x minus 1 equals 0. Okay, let's consider both of these cases. So for cosine x equals 0, what values of x does cosine x equal 0? Well, in terms of the principal root to this, cosine x equals 0 when x equals pi over 2, right? Or 90 degrees. So cosine x equals 0 when x equals pi over 2. Let's go over the other solution. So now we have 2 sine x minus 1 equals 0. I want to solve this for x. So now I get 2 sine x equals 1. I move the 1 to the other side. Then I divide by 2, and sine of x equals 1/2. Well, where does sine of x equal 1/2? Well, the principal root of that, the place where sine of x equals 1/2 is pi over 6, or 30 degrees. So when x is 30 degrees, the sine of that is 1/2. So now I actually have two solutions here. So my two solutions for x to this trigonometric equation are pi over 6 and pi over 2. Those are my two solutions, okay? And that's kind of a neat problem. I didn't graph this example because this would be a really gnarly graph, but we don't have to graph these. We just need to find the solutions to them. These are my principal roots to this equation, two solutions. Okay, this is a case where we needed to factor something out of our trig equation to solve it. That's a little more complex problem. Okay, let me talk about a final example, then we'll end the video. Okay, a final example has to do with what are called transcendental equations. Transcendental equations. Okay. Transcendental equations are basically equations where you can't isolate x. So these are you can't solve algebraically. You can't solve transcendental equations algebraically for x. There's just no way to do it. So, you know, we have these tools of algebra, but sometimes we can't do algebra to solve these equations. So are we stuck? Well, we're not totally stuck. What we actually can do is a clever technique. Let me give you guys an example of a transcendental equation. This is an example. Okay, sine of x equals x squared. There's not really an algebra. There's not a technique I know of algebraically. There may be one higher level, but I don't know of one that we can solve for x here. Sine of x equals x squared. However, we can still find the solutions. We can still find the solutions to this, and the technique we use is we graph sine of x and x squared on the same set of axes. And then we can find the points of intersection. So what we do is we graph sine of x and x squared separately, but on the same set of axes. We figure out where these two functions intersect, and where they intersect are the solutions. The values of x for which they intersect are our solutions. And what I'm going to do, the last thing I'm going to do here, is show you guys, is take you onto Desmos. So let me just log into my computer. Okay, my computer fell asleep. Let me just get in here. Okay, I'm going into my computer. I've got Desmos up. And now I'm going to bring the camera around, if you don't mind. Now you guys are looking at Desmos. What I'm going to do is graph y equals sine of x. That's y equals sine of x. Okay, can you all see that? And then I'm going, on top of the same set of axes, I'm going to graph x raised x squared, okay? I'm going to graph x squared, then I'm going to zoom in, okay? And what's cool is here, in blue you can see the solution for, in red you can see y equals sine of x. In blue you can see y equals x squared. And the places where these two functions intersect are the solutions to our transcendental equation. In fact, it looks like they both intersect at 0, 0 is one place. And that makes sense because the sine of 0 is 0, and 0 squared is 0. So one point of intersection is 0, 0. The other point, if we zoom in the other point, it looks like the other point of intersection is over right there. So I'm going to write these points on the board here, if I can do that. The two solutions, there's two solutions here. Let me put my camera back here in its original place. Okay, the two solutions to this equation are, one solution is the point 0, 0, where these intersect. In other words, this solution is x equals 0. The other solution, the other point of intersection, you can't see it here, but looking on here, it looks like it's approximately 0.87 for x, 0.87. And the other point is, for y, is 0.76. Okay, those are my 2 points. So in this case, x is 0.87. So my two solutions, this equation has exactly two solutions. My two solutions are x equals 0 and x equals 0.87. So this is a case where we had a trigonometric equation that we can't solve algebraically, but we still can find answers to it by using graphical techniques. We can basically graph sine of x, graph x squared, and see where they intersect, and those are my solutions. To give you guys one more view of it, one more view here. These are my two solutions. This is one solution, 0, 0. This is another solution, x equals 0.87, y equals 0.76. And that concludes our video lecture on transcendental equations. And I will see you guys on Tuesday, April 7th. All right, see you then.